All right, I'm going to work through this one like kind of quickly. Hopefully this is the easier one, but you stop me if you need me to go into more explanation, okay? Number 1 said sketch the line with point -1, 2, and slope 2/3. So I would have brought in a coordinate grid. I would have plotted the point -1, 2, and then I would have used that slope, which is 2/3, up 2 and to the right 3, or down 2 and to the left 3. And then you can make your line, sloppy line, but
we don't have to find B?
no. You could have, but you didn't have to.
Like I plugged in x and y into the y equals m.
And then you plotted it. It should be the same line.
I think it's because I started it at. I don't know what I did.
Okay, all right. 2 says fine. Sorry. Oh, okay.
Like I got y equals 2/3 x plus 8/3.
Yeah, exactly, because you're B.
Right. So then from 8/3, which is 2 and 2/3, you should go up 2 and to the right 3.
Yeah,
No.
I think I
Yeah.
forgot to.
Okay. Fine. The points will be different.
Yeah.
Okay. 2 says find the slope and the y-intercept. So my slope is m, which is this is already in y equals mx plus b form. That's 5. And the y-intercept, which is 0, -3. Remember we said intercepts have to be in coordinate point form. Number 2 says find the slope. So we're just doing y1, which is, y2 minus y1. So -12 minus 6 over 7 minus a -5. That becomes plus 5. And I get -18 over 13. That is really hard to read. Sorry. -12 minus 6 over 7 minus a -5. -18 over 12. And that becomes -6 over 2. Or, wait, did I do that right? 3. No.
No, -9 over
6. Yeah. Or 3, right? 6 and 4. Yeah. -3/2. Number 4 says find the equation with m equal to -2, and it passes through 2, -3. So now we're doing our equation. Y minus a -3 becomes y plus 3 equals -2 times x minus 2. Distribute that -2. Subtract the 3. And I get y equals -2x plus 1.
You could have also plugged in x and y, right?
Absolutely. Yeah, you can plug it into the y equals mx plus b form. You just have to then plug back in the m and the b. Yep. All right, number 5, find the equation that passes through 3, 4, and -2, 5. So first I got to find the slope. 5 minus 4 over -2 minus 3, and I get 1 over -5. So there's my slope, and then I can pick either point. So I'm going to pick the first point because it doesn't have any negatives, because that's where silly mistakes get made. Y minus 4 equals -1/5 x minus 3. I'm going to distribute the 1/5, -1/5, and then add the 4, and I get y equals -1/5 x. This would be 20 over 5, so I get plus 23 over 5. And you can leave it just like that. If I'm giving that answer as to like an equation, fine to stay how it is. If that was by chance something that you're graphing, then obviously you have to convert your b into a mixed number. But it's fine the way that it is. Okay, then 6, find the slope of a line that is A parallel to and B perpendicular to the equation from 5. So here's my equation from 5. My slope is -1/5. So what's the slope of a line that's parallel to that? Also -1/5. And what's the slope of a line that's perpendicular to it? +5. Now here's a little bit of feedback from the homework from 1-1. If I then said to find the equation of a line with those that like has the point -1, 2. I'm going to completely separate these out. I say it when I do the notes, but it's like I don't know how many times I have to say it for everybody to get it, so I'm going to say it again. You would use this point with the slope of -1/5, and then nothing carries over to the perpendicular one. You use this slope and this point. Still on the homework, people just grabbed the B from A and used it again for the perpendicular one. That's wrong, okay? The only thing that comes from the original line is the slope, and then you use the point, and you have to do it both times. I tried to like catch it and write a note if I could, but then I was just like, bro, I can't write that note one more time. So I'm just going to say it, okay? So that be really, really careful. All right, 1, 2, evaluate the function. So for 1, 2, and 3, we're just plugging in this value. So 2, negative 2 gets plugged in in parentheses. That's important because of the negative. Then negative 2 minus 1, I'd get 2 times 4 minus 2 minus 1, 8 minus 2 minus 1, 6 minus 1, which is 5. Then I get negative a. So 2 times negative a squared plus a negative a minus 1. Negative a squared becomes just positive a squared minus a minus 1. And you keep your answer just like that. 3, you're plugging in x plus 1. So 2x plus 1 squared plus x plus 1 minus 1. I'm going to expand and FOIL this out so I don't distribute that power. I'd get x squared plus x plus 1, which is x squared plus 2x plus 1. So that is 2 times that whole thing. Yeah.
In number 2, why do you keep the 2a squared? Like, why do you keep the exponent?
Because the variable's still got to be squared. It's just the negative that goes away.
But in one of the, I don't know if it applies, I think it was the first lesson, like, if it was squared, like, you do negative a times negative a, and it just becomes a.
No, it's still a squared. It's still a squared, yeah. So distribute here 2x squared plus 4x plus 2 plus x plus 1 minus 1. And then I'm going to combine all my like terms. So 2x squared is the only x squared. I get a positive 4x, a positive 1x, which is a positive 5x. And then I get 2 plus 1, which is 3, minus 1, which goes back to 2. Good on those. Okay, then domain. And remember that there's 3 things you look for domain. If there's a variable in the bottom, and if that's the case, we set that not equal to 0. If there's a variable under a square root, and if that's the case, we set that greater than or equal to 0. And if there's a variable underneath the square root in the denominator, we set it greater than 0 because now it can't be 0 either. If it's not one of those cases, like the first one under this section in the homework, if it's not one of those cases, your answer is all real numbers. There is no restriction, okay? For 4, I ignore the 2x in the top. There's a variable there, but 0 can be in the top, and 0 is still an answer. 0 cannot be in the bottom. So I would say that this cannot equal 0, and I get 3x cannot equal negative 1, and x cannot equal negative 1/3. For now, that answer is okay. We're going to eventually get into interval notation, where you're going to have to rewrite this as all the numbers except negative 1/3, and that would look like this. So for now, like I would say for today, that's okay, but as we move forward, you're going to start to write your answers in interval notation. So we'll review it again when we get to 1/3, but you need to know interval notation. 5, I've got the square root in the top, so this has to be greater than or equal to 0, and then I've got a square root in the bottom, this has to be greater than 0. I get x is, let me do that in color. X is greater than or equal to negative 1, and x is greater than a 3. This is an and statement, so I have to find the range in which both of these are true. If you need the visual number line, use it. Negative 1 is here, greater than or equal to that is from negative 1 all the way to positive infinity. Solid dot, bracket, doesn't matter, you're including that point. 3 to infinity is an open dot or a parentheses pointing towards the right. So you have to look for where these are both true, which means both lines exist. And that happens from 3 to positive infinity with an open dot. So this is a greater than 3. And in interval notation, it's 3 to positive infinity, like that. Mariana. Right, so that's why we don't say or equal to.
Why, but on the bottom, it wasn't that it can't equal.
No, remember, it's got to be greater than, because it can't be a negative if it's under the square root. If the square root wasn't there, it would just not be equal to 3.
It has to be greater.
Because it's under a square root, it has to be greater. Because you can't square root a negative number. That's what you're basically saying.
Okay.
Are we,
Oh, sorry, yeah.
are we not doing the negative 1?
So you want to go where it's only overlapping. From here to here, right? From here to here, it would be okay for the numerator, but it would give me a negative in the denominator, so I can't use it. You can only go to where it's both. Pick a number here. Call it 0. 0 plus 1, totally fine. Square root of 1 I can do, right? 0 minus 3, I get a square root of negative 3. Can you square root negative 3? No. So you have to go to where both of these are true, and that happens over here.
So you actually have to like solve, like plug
You
in
don't-
the number?
No, that's just fine.
I thought like negative infinity to negative 1 because I thought it included.
It has to be
-1.
greater than it, right? This is not a not
negative
equals.
infinity is it? Oh,
It has to be
okay.
greater than. Yep, and then it has to be true for both of them. Got it? All right, so I lied about, oh, sorry.
Why is the top greater than or equal to?
Because it can be 0 in the top. 0's okay. 0 in the top is 0, that's an answer. But 0 in the bottom is undefined. So it can't be 0 in the bottom.
So the rules for like when we insist there's a variable in the denominator can equal 0, square root at the top it has to be greater than or equal to,
Yep,
and then if it's on the bottom it's just greater than.
correct. Yep,
Those are the only three for the domain.
yep, and then everything else is all real numbers.
Okay.
Yep. Okay, so I lied about going over the homework today. It's going to be on the video, the difference quotient. So why are you frozen? There we go. Okay. 1, 2, part 2. We're going to cover something called the difference quotient. Whether you are in Algebra 2 regular or Algebra 2 honors, you have never seen this before. Okay, so this is like a level. That's the stuff from yesterday. Okay. This is the difference quotient. F of x plus h plus f of x over h. That's another thing you got to memorize, okay? That is the difference quotient. Again, f of x plus h minus f of x over h. It looks so very complicated. You already know how to do all the parts of this. We're just going to put it together, okay? I think I have time for 2. Yeah. I'm going to start with this one, so add 1 in because we're going to baby step our way in. Add a slide in. Okay, so this is the problem. This is what f of x is. It's going to give you what f of x is. And then it's going to say find the difference quotient. There are 3 parts to the difference quotient. F of x plus h, f of x, and h. Okay? I'm literally going to separate them out. So the first thing I'm going to do is f of x plus h. So let's pretend that we're not even doing the difference quotient. Let's just say I gave you f of x is 2x minus 3. And then I said find f of x plus h. How do you do that?
Wait,
If you give us like 2x minus 3.
If I gave you f of x is 2x minus 3. And then I said find f of x plus h.
Do we plug it in the x?
Yep. I'm going to take this and I'm going to plug it into the x. So I'd get 2x plus h minus 3. I distribute that 2. Oops. And I get 2x plus 2h minus 3. Can I simplify that? Nope, it's ugly, but it's the whole thing. That is going to replace f of x plus h. Not yet, but it will.
how do we know that?
So it's always the same steps. If it says f of x plus h, you're going to take x plus h and plug it into the question. Then that makes up this part of my difference quotient. What's f of x? 2x minus 3. So this part is going to get replaced with f of x, and then h stays as h. So I'm going to plug it in. I'm going to take the f of x plus h and replace it with 2x plus 2h minus 3. I'm going to subtract from it 2x minus 3, and I'm going to put it all over h. So the pink part came from plugging in x plus h into my question. That is always what you will do. The red part is my question, and it all goes over h. Now I just got to simplify. So the negative is going to get distributed here. I'd get 2x plus 2h minus 3 minus 2x plus 3 all over h. Do we see stuff we can simplify? Cancels out. Negative 3 and positive 3 cancels out, and I get 2h over h, which is just 2. If you do it correctly, you will always be able to cancel things out, and you will always be able to cancel in the h. It may not always result in one term, but you'll always be able to simplify it. I'm going to do another one.
So we don't do anything like with the f? Because aren't we plugging in 2x minus 3 for the x?
No, for the f of x. So f of x is that whole thing. You're replacing the entire term. Yeah. All right, same exact difference quotient. F of x plus h minus f of x over h. The only thing we have to find is f of x plus h. This time, it's squared. Everywhere there's an x, which this time there's 2, I plug in x plus h. You're going to take this part we're doing first. So I'm taking x plus h, and I'm plugging it in to my question everywhere there's an x.
Only x plus
Yeah.
h.
We're going to do it in parts. Then I expand this out. Foil it. And combine my like terms. And then you curse me because you had to write that so many times because there's a lot of terms there. So this whole thing is the f of x plus h part.
How did you get from, how did you get to the first thing, x plus h?
I just expanded. Oh, like how did I write this line?
Yeah, where did you get
You're taking x plus h and you're plugging it in everywhere there's an x in your question. Right? This went here, so it was squared, and it went here, so you do negative 2 times it.
So if you plug in the negative x squared minus 2x?
No, you're plugging the x plus h into that. Other way around.
Okay.
Now I'm going to subtract from this.
It's the opposite
No,
now.
it's how we always did it. I gave you an f of x and then told you to do f of something, and you took whatever that something was and plugged it in. All right, 2 seconds. I'm going to subtract my question. And I'm going to put it all over h. This gets distributed. So this becomes plus. This becomes plus. I cancel, and I'm going to be able to cancel again. X squared, negative x squared, negative 2x, positive 2x, negative 5, positive 5. I'm going to rewrite what's left. It all goes over h, and if you do it correctly, you can cancel through the h's. Hello, sir. Oops. And there's your answer. Yeah, I just did it. Yeah. Yeah.